Robots are everywhere. They build our cars, save lives, and even explore distant planets. Well, this is my robot, and it's pretty useless. So today I'm gonna take all my engineering knowledge and teach him how to high five. Have you ever wondered how this robot walks? I mean, each leg moves in a straight line, so the robot goes forward, and then it lifts up and returns to the starting position. But how do you explain this to the robot? So this is the leg of the robot. It has 3 motors, and what you can do is to rotate each motor by some angle, and the leg will move to some random position. But what if you wanted the leg to follow this curve, so it actually makes the robot move forward? Well, then you want the exact opposite, because this curve is defined in spatial coordinates. So we want something that when you input the spatial coordinates, you get out the angles. And the function that calculates this is called inverse kinematics. Don't mind this leg, we'll get to that later. So instead of setting these angles and letting the leg move to some random position, I tell the code to move the leg, let's say 50 millimeters that way, and the code calculates these necessary angles. To generate this curve, I wrote a code, and I saved all of the points of the curve. I'm feeding these points to the robot, and the robot calculates the necessary angles. But what if I wanted to do more advanced movements? Like, what if I wanted to tilt this robot, or make it do high fives? I would have to write a code that generates curves for each of the legs, and I could do that, but I have a better idea. This is Blender. You can do many things with this program, but I'm using it for animation. So I've made this animation, and then I wrote a script that saves the positions of the legs. And when you run the script, it generates this text file with all of the positions, and it also generates this bit of a code to make my life easier. Then I just take this and paste it into my main Arduino code, load it to the robot, and it does exactly what the animation does. So instead of generating curves for each of the leg, I just do this animation and then I paste it into the main script. And you might think that if I wanted to rotate the body, I would need to save its position too, but the 6 positions of the legs actually completely define the movement of the whole robot. And this took me like 5 days, but now it would take only 20 minutes. So just to recap, I rotate the robot in Blender. The Blender generates the spatial coordinates, which I paste to the Arduino. And the Arduino calculates the inverse kinematics and outputs the angles of the motors. So I control the animations of the robot with this controller. And don't be fooled by the beautiful design, it's actually pretty shit. It only has 1 button and I need at least 3. So I'm gonna upgrade the controller and then I'm gonna make him high five. In case my voice didn't give it away, I'm super excited. Actually, because even though my channel is small, I've already secured my first sponsor. And it's PCBWay. Do you see this mess? PCBs let you transform all the ugly wiring into a nice little circuit board. And designing them isn't even that hard. I've designed my very first PCB in 2 days. And if your PCB is small, it costs only $5. So if you want to upgrade your project with PCBs, go to PCBWay and you'll get a $5 discount for your first order. These helping hands are great. Man, I hate soldering, but this is cool. Dopey. Nice. Alright, let's make some animations. For the high five, he just lifts up his leg, waits for the hand, and then executes the high five. Now, this robot has 6 legs, and each leg has 3 degrees of freedom, X, Y, and Z, so that's 18 vectors. And these 5 legs aren't moving, so to save space, my code ignores them, which is why the vectors have only a single element. Okay, so now I want to make the robot dig. So at first he's gonna sit back like this. And then he's gonna dig into the ground with his 2 front feet. Okay, so this is the first animation, he just sits. And now I'm gonna make second animation where he's actually digging with his feet. Okay, that's it. I'm not gonna animate the second leg because it's just the mirror of the first one. And this is again to save space. Now in the Arduino code I just pasted the animations. And I have these 3 states: sit, dig and high five. And to go from one state to another, I'm using a switch case structure. So when I press the sit button, it's gonna activate state 20 and it's gonna execute only this part of the code, which is the sitting animation. And then when I want to go to the dig state, I just press another button and it's gonna execute the digging animation. And this type of programming is commonly used in embedded systems, and I've also programmed this robotic arm the same way. Alright, let's have some fun. We are getting close to the finish line. After I fix this leg, I'll make a video covering the whole 1-year build. But now, make sure to watch my playlist where I built the robot from day 1.